Hi geometry classes, this is the circle unit lesson 6 and today we're going to talk about intersecting chords, secants, and tangents and the angles that are formed by them. So our first rule right here is if I have two secants or chords, all right, that are intersecting inside a circle, so that's going to be important because we're going to do some in a minute that are going to be outside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. All right, so let's look at this. First one, let's find measure of angle 1. So angle 1 is right here. So the rule is it's the measure of half of the intercepting arcs. So basically, look at the arrows that I drew. It's the arc to the left and the arc to the right. All right, so it's going to equal half arc AD, which I have in green, plus arc BC. So basically you're taking the average of the arcs to the left and the right. So this is not a central angle. All right, we learned about central angles. Central angles, their vertex was in the center. This is just any angle formed inside a circle, and it's formed by either two chords or two secants. And angle 2, grab a different color right here. Angle 2 is going to be half of the arcs that are going up and down. So it's 1/2 the sum of the intercepted arcs that are either above and below or to the left and the right, depending on how that angle looks. So angle 2 is going to be 1/2 of arc AB plus arc CD. All right, so let's look at it in terms of like a real problem. So in this first problem, I want to find angle AED. So AED, which is right here. I'm going to put a yellow dot right there. All right, so it's this arc and this arc. So I'm going to do 1/2 of 45 plus 109. You're finding the average of those two arcs. All right, 49 plus 109 is, let's see, 9, 10, 11... 151. Oops, I wrote 42 by mistake. Sorry about that. I was wondering why the answer on my paper was different. It's 45 plus 109. So that's 156, and then I take half of that. All right, and actually not 156. Making mistakes all over the place. 154, so that's 77. Okay. Let's try and find another one. So I want to find STR. So STR is right here. So it's going to be the arcs that are above and below. So I'm going to do 1/2 of 112 plus 186. So that's 1/2 of 298. And you're just using a calculator for all this math. Is 149, as long as you understand the rule. So any angle inside a circle is equal to 1/2 the intercepted arcs that are on either side of that angle. All right, let's look at this next one, angle WYX. So WYX is right here. Okay, so basically the rule is it's 1/2 the arcs that are on either side, but look at that, I don't have any of those arcs. So what I'm really going to do is I'm going to first find this angle, which is 1/2 of those arcs, and then where I put the red dot and the yellow dot, those form a line. All right, so once I find the angle VWY, then I'm just going to be able to subtract from 180. All right, so I'm going to do 1/2 of 43 plus 81. I'm going to find angle VWY. So that is 124. 1/2 of 124 is 62. All right, and now that I know that that angle is 62 right there, to find angle YWX, it's just going to be 180 minus 62. There we go. All right, so sometimes you might have to play around to figure out what's going on. All right, ultimately on number 4, I want to find the measure of arc LK. All right, so that's arc LK, which is right there. Now this one's different because I gave you the angle. So remember the rule is the angle equals 1/2 the arcs, the sum of those arcs. Well, I know the angle's 62. I'm missing one of the arcs, but I do have the other arc. Okay, and it's just going to be a matter of solving. I think the easiest thing to do, instead of distributing that 1/2 to everything in the parentheses, to get rid of the 1/2, you multiply by 2 to get rid of it, but that means you have to multiply the other side by 2. So that's probably the easiest thing. So I have 124, but then I don't have the fraction anymore. I just have a regular equation. And to solve for x, I'm subtracting 74. X equals 50. All right, second rule. Sometimes my angles are not central angles, and they're not inscribed angles, and they're not inside the circle, and they're not outside the circle. They're sort of on the circle. So if a secant and a tangent, and just to remind you guys, a tangent is a line that touches the circle once, and a secant, okay, is a line that goes through the circle. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. All right. This is not exactly the same rule as an inscribed angle. I mean, it looks a little different, but it looks really similar. So I always just think of it as an inscribed angle rule. So angle 1, which is right here, is just going to be equal to half of arc BA. And angle 2, which is on the other side, okay, right there, is going to be equal to half arc BCA. So it's not really an inscribed angle, but it's the same rule, and I think it looks similar to an inscribed angle. So it's just going to be half of that intercepted arc. All right, so we'll just look at some right here. I want to find the angle of angle DEG. So DEG is this angle right there. All right, the arc that it matches up with is this arc right there. So all I'm going to do is I'm going to take half of 308. And half of 308 is 154. 6, I want to find angle DBC. Now DBC is actually here on this side. Okay. Well, I know that this arc is 192, but I really need to know this arc over here. But they just form a complete circle. So all I have to do is 360 minus 192, all right, and that's 168. So the arc is 168. So the angle DBC, angle DBC is half of arc 168, 84. Okay, and arc XY is over here, but I think the easiest thing to do would be to find this arc. See how the angle is, let me get a different color. The angle right there, WXY, is 151. Well, that makes this arc 302, right? Remember, the arc is twice the angle. And then a full circle is 360, so I'm just doing 360 minus 302 is 58. Okay? All right, and last set of rules. Exterior angles. So sometimes I have secants and tangents are intersecting on the exterior of a circle. Then the measure of the angle formed is equal to half the difference of the intercepted arc. All right, so if I'm trying to find angle A right here, let me just highlight those so they stick out a little bit more. Angle A, all it's going to be is half of this arc minus this arc. It's always the bigger arc minus the smaller arc. So it's going to be 1/2 of arc CE minus arc BD. All right, so if they were, a minute ago we did angles that were inside the circle, they're 1/2 the average of the arcs, the sum of the arcs. This time I'm doing arcs that are outside the circle. This is a secant and a tangent, but it's going to be 1/2 the difference of the arcs. So if the angle is outside the circle, it's 1/2 the difference of the arcs. If the angle is inside the circle, it's 1/2 the sum of the arcs. So I'm just showing you examples with 2 secants, a secant and a tangent, and 2 tangents. Remember, a tangent intersects a circle in one spot, The secant intersects a circle in two spots. They all have the same rule though, in that it is 1/2 the difference of the arcs. So 1/2 of arc BDC, and it's always the bigger arc minus the smaller arc. All right, and we're just going to practice that. So I want to find angle KLM. Right, and all I'm going to do is 1/2 of the difference of the arcs. The bigger arc, which is 140, minus the smaller arc, which is 66. And that gives me 37. Right, so I got these two right here. Now on this one, interesting, they didn't give us one of the arcs. I'm going to have to figure out what that arc is. So I'm just going to do 360 minus 313, because those two arcs together form a complete circle, is 133. So now I have the arc. And the angle is just 1/2 the difference of those arcs. 313 minus, what did I do here? I don't know how I got 133. Sorry, guys. I'm doing all sorts of weird subtracting. All right, so when I subtract that, that gives me 47. All right, 1/2, 313 minus 47 is 133. And you can do that in your calculator, that part. So this was 47. There we go, all fixed. All right, and let's do one where I'm going to have to figure out the arc a little bit more. So I'm trying to find angle ABC, so it's going to be this arc minus this arc. The problem is I'm missing one of those arcs. So I'm going to take the 88 and the 62, add them up, is 150, and then subtract from 360, because I need to find that missing arc. So that missing arc right there is 210. Now I can do my problem. So the angle equals 1/2 210 minus 62. Okay. And let's see, this one is different because they're giving me the angle and they're giving me one of the arcs and they're not giving me the other arc. All right, but it's still the same thing. The angle equals 1/2 the difference of the arcs. The angle is 40. It has to be the bigger arc minus the smaller arc, so it's x minus 75. Now remember what we did before. To get rid of that fraction, I just multiplied by 2. Gone, but I have to multiply the other side by 2. So 80 equals x minus 75, and then I'm just adding 75. All right, so just showing you a variety of different problems. And the last one that we're going to do, I'm going to show you a problem that has an equation in it. So let's just highlight all that. Let's see what we got. So arc NJ is 170. Arc MK is 5x plus 8. And angle MLK is 4x plus 3. So remember, the angle equals 1/2 the difference of the arcs. So the angle is 4x plus 3 equals 1/2 the difference of the arcs, 170. That's the bigger arc, minus, now you have to subtract that whole thing, so I need parentheses around it. I'm going to do the same thing as before. I'm going to get rid of that 1/2 by multiplying by 2, but that means I have to multiply the left by 2. So that 2 is getting distributed. It's 8x plus 6. The 1/2 is gone. 170 minus 5x minus 8. That negative sign has to get distributed to everything. All right, let's bring that 5x over to the right, to the left rather, by adding it. So 13x plus 6. I'm going to combine the 170 and the minus 8. Then I can subtract 6, and then I'm just dividing by 13. So yes, I can do that same rule with an algebraic problem. Just be careful with those negative signs. Right? So we're going to practice all that tomorrow.